Hello, let's work another limiting reagent problem. Let's look at this reaction. C5H12 plus 8O2 reacts to make 5 CO2 and 6 H2O. What we're doing is combusting pentane. We're burning it with molecular oxygen to produce carbon dioxide and water. And the molar ratios are 1 mole of pentane to 8 moles of oxygen. They react to make 5 moles of CO2 and 6 moles of water. So let's say we have 67.5 grams of pentane and we have 182 grams of molecular oxygen. And let's calculate the grams of CO2 that are produced. This is a limiting reagent problem, and that we're given the masses of two reactants, and we don't know if we have the exact amount of each to stoichiometrically react, to exactly react with each other. So we're going to work this problem like we do our stoichiometry problems. We're going to go from grams to moles to moles to grams. Whenever we convert from grams to moles or vice versa, we're going to use a molar mass. And whenever we go from moles to moles, we're going to use a stoichiometric ratio. That comes from the coefficients to our balanced chemical equation. So what we're after is, what is the theoretical yield of CO2? So what we're going to do is we're going to take pentane, that mass, and work it all the way through till we get gram CO2. And then we're going to take the mass of oxygen and work it all the way through this process till we get gram CO2. Then we're going to compare the two masses, and whichever one is the smaller amount, that will be the correct answer. That will be have been determined from the limiting reagent. And the other reagent will be the one that's in excess. So 67.5 grams of pentane, C5H12, 1 mole of C5H12. It's the same as 72 grams of C5H12. Get that from the periodic table. Grams pentane divided by grams pentane cancels. And now we need to come up with our stoichiometric ratio of moles pentane, C5H12, to moles carbon dioxide. And so we look back at our equation, and we see that it's 5 moles of carbon dioxide to 1 mole of pentane. 5 moles CO2, 1 mole of pentane. Moles of pentane would cancel. Now we got to convert moles carbon dioxide to grams carbon dioxide. And it's 44 grams of carbon dioxide per mole. Now moles carbon dioxide cancels, we wind up at grams carbon dioxide, and we will see that we will produce 206 grams of carbon dioxide if all 67.5 grams of the pentane is consumed. But we're not finished. We have to work it through using the other reactant. 182 grams of oxygen, molecular oxygen, O2. We need to work that through to see which one winds up being the limiting reagent. So we need to convert grams CO2, grams oxygen to moles oxygen. So 1 mole of molecular oxygen, O2, is 32.0 grams. So grams oxygen divided by grams oxygen. Now we need to come up with our stoichiometric ratio that converts moles oxygen to moles carbon dioxide. And we look back up at our balanced chemical equation. It's 5 moles of carbon dioxide are produced, for every 8 moles of molecular oxygen that's consumed. That's our stoichiometric ratio. So now moles O2 cancels. We've got moles carbon dioxide. And now we can change moles carbon dioxide to grams carbon dioxide using the molar mass, which is 44. So mole CO2 divided by mole CO2 cancels. And we do that calculation. We will come up with 156 grams of carbon dioxide. So now it's decision time. Which one is the limiting reagent? We look at the two amounts of carbon dioxide produced, and whichever one is the smaller one, the lesser one, that came from the limiting reagent. So 156 is smaller than CO2, so that means our oxygen, molecular oxygen, is the limiting reagent, and our pentane was our excess reagent. The only way to get to this point is by working through this process. We can't look at just the mass amounts to starting out with, because if we did, we would have seen a smaller mass of pentane, and we might have gone, aha, that's going to be the limiting reagent. But it's not, because we have to factor in the stoichiometric ratio. If you want to stop here, that's fine, and just concentrate on this of coming up with a limiting reagent. In the subsequent part of this video, I'm going to take these calculations a little bit further to drive home more about doing this mole to mole ratio. Let's take this a little bit further so we can practice using our stoichiometric ratios and get a better understanding also of the law of conservation of mass. We said that the pentane was our reagent in excess. So how much pentane was consumed? What we're really asking is how many grams of pentane. So we're going to base our calculation on the limiting reagent. So our limiting reagent was the oxygen. So 182 grams of oxygen. Convert that to moles, and that 1 mole of oxygen is the same as 32 grams of oxygen. Grams oxygen divided by grams oxygen. Now we need our stoichiometric ratio. We go back to our balanced chemical equation that said that C5H12 plus 8O2 react to make 5 carbon dioxide plus 6 water. And so for every 8 moles of oxygen, we consume 1 mole of pentane. So now moles of oxygen cancels. We've got moles of pentane, but we want grams. And so the molar mass of pentane is 72.0 grams per mole. So now moles of pentane cancels. We're left with grams of pentane. And so we wind up getting 51.2 grams of C5H12 were consumed. So how many grams of pentane were unreacted? And so we started out with 67.5 grams that we started out with, and we reacted 51.2 grams. That will give us the unreacted amount of pentane. So 67.5 minus 51.2 will be 16.3 grams of pentane that was unreacted. We did this by using the law of conservation of of mass. We can take this reaction even further. We can calculate the mass of water produced. So once again, we're going to go back to the limiting reagent. The limiting reagent was oxygen, 182 grams of O2. 1 mole of oxygen is 32.0 grams of oxygen. Grams oxygen divided by grams oxygen. Our stoichiometric ratio of moles oxygen to moles water, H2O, go back to the balanced chemical equation, it's 8 moles of oxygen produces 6 moles of water. Now moles oxygen cancels, and now we can convert moles water to the mass of water. It's 18 grams of water is the molar mass of water. We got that from the periodic table. So now moles divided by moles cancels. And that will give us 76.8 grams of water produced. So let's review what we've done here using the law of conservation of mass. Our chemical equation was pentane, C5H12, plus molecular oxygen, 8 moles of that, reacting to make 5 moles of carbon dioxide, plus 6 moles of water. So at the start, we had 67.5 grams of pentane and 182 grams of oxygen. At the end, all our limiting reagent was consumed. There was no O2 left. We had 16.3 grams of pentane that was unreacted, so we still had that at the end. And we had produced 156 grams of carbon dioxide and 76.8 grams of water. So we had predicted and calculated that we had 51.2 grams of pentane that was actually consumed. So the mass of our reactants has to equal the mass of our products. So our mass of our reactants, 51.2 grams of pentane plus 182 grams of oxygen, should equal the mass of our products, 156 grams plus 76.8 grams. And so 51.2 plus 182 is 233.2 grams, and 156 plus 76.8 is 232.8 grams. And so we're plus or minus 0.4 grams. That's certainly good enough for government work, so to speak. And so that's, we had some rounding error in there. We didn't carry on the significant figures. If we'd done that, we would have come right on the mark with the same amounts for both. So that shows the law of conservation of matter. One last thing to do with this problem to show what else could possibly be asked in these problems. Let's calculate the percent yield if only 62.2 grams of carbon dioxide are recovered. And so percent yield is equal to actual yield divided by the theoretical yield times 100%. So our theoretical yield of carbon dioxide was 156 grams. We said that we only recovered 62.2 grams. We'll multiply that by 100%. So 62.2 divided by 156 times 100 will give us 39.9% yield. So this has been an extended video with this one particular problem to show you how many different calculations could be gotten out of this particular example. And so you're welcome to go back and replay different parts of the video and clear up any questions that you might have, and make sure that you understand going from grams to moles to grams, doing the comparison of both reagents to see which is the lesser amount. That's will be the correct answer, and that came from what the limiting reagent was. The other reagent had to be the reagent in excess. The law of conservation of matter has to be confirmed, and you might have to be asked what the percent yield is. And also you could be asked what amount, how many grams of the reagent in excess were not consumed. Lots of things to do in terms of stoichiometry and limiting reagents.